Math 1, Unit 2, Lesson 9.1, so Arithmetic Sequences. So we're dealing with some more sequences here. Remember, for arithmetic, they grow by repeated addition or repeated subtraction of the same number. Okay? And so that number that we're adding or subtracting by is called the common difference. Okay? Then we also have the two different formulas. We have the recursive and the explicit. Remember, the recursive connects an output to an output. So on a table, it's connecting these answers, right? And how they grow and where they start. Okay, but it's always connecting the outputs. Whereas the explicit connects the input to the output. So once again, we have a starting point and we have the growth, but that growth, understanding that growth connects the input to the output. Okay? So, and when it talks about the nth term, that's just the variable. Okay? So essentially they're saying find the equation of it. Alright, so question 1. 27, 31, 35, 39. So we make this table, right? And remember that that's the first term. Okay, second term, third term, fourth term. We want to go back and find the zero term, but first let's find that common difference. So 27 to 31 to 35 to 39. Hopefully we can see we're adding 4 each time. So that's our common difference, a positive 4. So if we're going backwards, we would subtract 4 from 27, right? Because we want to go back to this one. So it would be some number plus 4 equals 27. So if we subtract that, we get 23. Okay. Now, remember, for our explicit formula, the idea is that from where we started at, with that common difference, we're taking 23 and adding 4 to it. The second time, we take 23 and we add 4 to it twice, right? Okay. Except we don't like to write that way because we're trying to come down to the nth term. So it'd be 23 plus 4 n number of times. Okay. So what we notice with the pattern is when we start with 0, whatever our input number is, that's how many times we're adding 4. Okay, and we have a shortcut for writing repeated addition. It's multiplication. Okay, so in other words, this would be 23 plus 4 times 0, 23 plus 4 times 1, 23 plus 4 times 2, and so on. If we went 3, if we went 4, it would work the same way. Notice that we have our starting number here, we have what we're growing by, and we have our input. Because it's explicit, we're connecting the input to the output. So for this one, it would be 23 plus 4 times n. Okay, so we go. Sometimes you can write y equals or f of x equals. For this time, we're going to write a sub n, right? That's for sequences, that's a format that they like to use. Then we start with our starting number. What did we do to it? We added 4. How many times? N amount of times. There's what we need for our answer. Okay, so I won't go quite so in depth next time, but if you need to, write your stuff out like this to see that pattern to help you with your equation. Okay. Alright, number 2. So still doing the same thing. So make a table. That's my 0 term, my first, second, third, fourth. 4 to negative 3 to negative 10 to negative 17. These last ones are probably easier to see that we're subtracting 7 each time. So common difference, negative 7. So going backwards, we would add 7. So 11 minus 7 would give us 4. So we've got our start number. So I go a sub n equals my start number, 11. What are we doing to it? We're subtracting 7. How many times are we going to subtract 7? We're just going to keep going. So the shortcut version would be multiplying that by n. That's all there is to it. Okay. Now once again, this explicit formula, we could rewrite it y equals 11 minus 7n, or y equals negative 7 plus 11, and that n right there. We could do f of x even, and go 11 minus 7x. Okay, and we'll use these versions more often later on. So for right now, it's alright if we just stick with this one. Just realize this a sub n stands for the output, just like y does, just like f of x does. N is our input, a sub n is our output, okay, and this formula connects them. That's what explicit does. Okay, number 3, same idea. Make that table, first term, second term, third term, fourth term. We want to go back to the 0 term. So negative 101 to negative 87 to negative 73 to negative 59. So bigger numbers, right? If you're not sure, just go 101 minus 87. So we borrow, that would be 4, that would be 9. So it looks like we have 14. They're getting smaller negatives, so we'd be adding 14. So common difference, adding 14. So if we're going backwards, we'd subtract 14, so it would be negative 115. So a sub n equals negative 115. My 0 term is our starting point. What are we doing to it each time? We're adding 14. How many times are we going to add 14? N amount of times, so times by n. Hopefully these aren't looking too bad now. Okay, number 4. Now these ones we're dealing with fractions, so these can be a bit trickier, right? First, second, third, fourth term, 0 term. So 1/2 to 5/2 to 9/2 to 13/2. Okay. Now notice our denominators are all the same. So our denominators aren't changing, right? Now we're either adding or subtracting a number here to get these to the next. So when we add fractions, we need common denominators, right? So the number I'm adding by has to be a common denominator, so I know it's 2. Now, this stays 2, so I know that we're not having to deal with our denominators. So I need to figure out 1 plus what would give me 5. Well, that's pretty easy, right? 4. Okay, so 4 over 2. If I add those, that gives me 5 over 2. What about, will it work to get 9? 5 plus 4 gives me 9. 9 plus 4 gives me 13. Okay, so I'm adding 4 over 2. Now, we can simply leave it like that, or we could realize 4 over 2 is the same thing as adding 2, which is, those are the same number, they're equivalent numbers. So it doesn't matter which one I use. Okay, so going backwards, we'd have to go 1/2 minus 2, or minus 4/2, which would give us negative 3 over 2. Okay, or if you liked the decimal version, negative 1.5. Okay, but I'll just use the fractions. So I'd go a sub n equals, oh, so these are my common difference. Either way you write it. A sub n equals negative 3/2 plus 4/2 times n. Or negative 3/2 plus 2 times n. Or negative 1.5 plus 2 times n. Either one of those would work. Alright. So let's take a look at number 5 now. 5 and 6. Now this time they gave us the recursive formula. Okay? Remember, the recursive formula has the first term or the 0 term. Sometimes we'll do it with the 0 term. Okay? So that's the number we're starting with. So if I'm writing a list of numbers, you know, I know the first one here is 3.2. Okay? Then they want us to find the rest to make 5. Okay? So, remember when we're dealing with recursive, this part, a sub n, it's an output. A sub n minus 1 is also an output. This is like to get the next number. So if we're doing a table, we're saying we want this term. How do we get this term? Well, we need the previous term to get that. A sub n is the previous term. And then this is the growth. So every time we're adding 2.7. That's our common difference. Okay, is adding 2.7. So start at 3.2, add 2.7, that would be 5.9. Add 2.7 to that, that would be 8.6. Add 2.7 to that, that would be 10. And 0.6 and 0.7 would be 1.3. So it would be 11.3. And then add 2.7 to that would be 13. 0.3 and 0.7 would give us 1, so 14. And there's the first 5 terms. Now, if I wanted to make an explicit equation of this, I would have to go back to the 0 term, right? We'd have to get this guy. This is 3.2, 5.9. So going backwards, we'd have to get probably just 0.5, wouldn't it be? 0.5 and 0.7 would give us 1.2. 2 and 1.2 would be 3.2. So that would be the only difference, is I get that for my starting number, and I'd go a sub n equals 0.5 plus 2.7n. Notice that we have a lot of the same numbers kind of go along with that one in each one. The difference is instead of an a sub n minus 1, we have an n, because that's an input, not an output. Alright, let's try number 6 now that we understand the idea. So a sub 1 equals 18, that's where we start. We want to get the rest of the 5 terms. To get the next term, we take the previous and we subtract by 22. So that's the common difference there is negative 22. So 18 minus 22 would give us negative 4, minus 22, negative 26, minus 22, negative 48, minus 22 would be negative 70. Okay, and that's all we have to do for those ones. Alright, now the last 4 are story problems. So, you have read 25 pages of a book. You plan to read an additional 10 pages each night. Write the explicit formula to represent the number of pages you will read after n nights. Okay, so this is where it can get tricky, because is this the first term or is this the 0 term? Okay, most of the time I would just assume it's the 0 term and I'd start from there. Okay, but it would probably be the first term because we're dealing with sequences, and they're always considering this the first term. So if I make a table, my first term would be 25, and I'm adding 10. So my common difference is adding 10. So 35, 45, and so on, right? Till we get to the nth term. So going backwards to the 0 term would be 15. So I would go a sub n equals my starting number, 15, plus my common difference, 10, and we just keep adding 10 to each one, right? So that would be n. Now, if you wanted to do the recursive formula, that would be easy too. I could go a sub 1 equals 25, or I could go a sub 0 equals 15, doesn't matter. Then I'd go a sub n equals a sub n minus 1 plus 10. Remember, with recursive, this is always the same, this is always the same, that's always the same. The only thing that changes is our start number and our growth. Okay? Number 8. You are going on vacation. You have $105 to bring with you. You expect to spend 15 each day. You want to have 30 remaining at the end of the vacation. Write an explicit formula to represent this scenario. For how many days can you spend $15 each day? Okay, so we know we've got 105 that we're bringing with us, right? We're spending 15, so our common difference here would be subtracting 15. Okay, so I would consider this to be the 0 term, since we haven't spent anything yet, and we're talking about days when we're spending. So that's 105, or 150 if you're transposing your numbers like me. And then we're subtracting 15 each time, right? but we want to have at least 30 remaining at the end of the vacation. It didn't say at least. Okay, so it wants an explicit formula again. So remembering that I'd be subtracting 15 each time, we're trying to get down to the n term or even the x, either one works. So I'd go y equals, or a sub n equals, 105 our starting. We're subtracting 15 each time until we get to n. Okay, now let's say we want to have $30 remaining. So how would we deal with that? Well, this a sub n or this y, okay, doesn't matter which way you write it, same thing. Okay, that would be 30. And we could solve. You could use a table and figure it out that way, right? This would be 90, this would be 75, it would be 60, and you could go down till you got to 30. Or we could solve for n. So I'd subtract 105. So we'd get negative 75 equals negative 15n. Divide by negative 15. And n would equal, what is that? 7. 15 times 7. 5, 3. Oh, that's 105. So it would be 5. 15 times 5. Yeah. 5, 2. So it would be 5. So 5 days. Okay. In 5 days, you don't have $30 left. And so if we kept going for 5, we would get that to 30. Okay? Alright. So, number 9. A bicyclist. Oh my goodness. I can't pronounce that word right now. This is kind of freaking me out. A cyclist, I'm just going to say it that way, is training for a race. On the first day of training, she rides 12 miles. Okay? So in this case, she said the first day of training, she rode 12. She increases the distance she rides by 3 miles each day. So our common difference, we're adding 3. So she will ride 15 miles the second day, 18 miles the third day. So how many miles before? We'd probably consider that 9. Write an explicit formula to represent this scenario. How many miles will the bicyclist ride on her 9th day of training? So we could keep just going like this until we got to 9. Counting by 3s isn't that bad, right? 21, 24, 27, 30, 33, 36. Okay, so we can answer that on our 9th day of training. She's going 36 miles. Okay, so we can do it. Sometimes that's easy enough to do. But on other numbers, it's not so easy. Okay, so that's where that explicit formula helps us out, right? Because what we just did was essentially what the recursive does for us, which works. So we would go a sub n equals our 0 term 9. Okay, then what are we doing? We're adding 3 each time. How many times? We did it 9 times, so normally we go times 9. But for our explicit formula, we want the variable of that, so it would be n. So we get a sub n equals 9 plus 3n. And then we went 36 miles. So if we wanted to find how many miles we went on the 9th day, I would plug in 9 for 3, so I'd go 9 plus 3 times 9. Okay, 3 times 9 is 27, plus 9 gives us 36. So our output, our a sub n, is 36. Alright, last one on this one. Sophie needs to complete community service hours for her service club. She needs to complete 150 hours to earn a merit badge. Sophie has already completed 65 hours. Write an explicit formula to represent this scenario. If she volunteers 5 hours each week, in how many weeks will she have completed the hours to earn the merit badge? So in this one, I would probably call 65 my 0 term, because it doesn't say like the first day. Okay, it says she's already done. So honestly, we could have put that as the 0 term as well, but it works. Okay, so then 1, 2, 3. Okay, so she needs to complete 150. She's doing 5 hours a week, so this would be like our weeks and our hours. So we're adding 5 each time. So 70, 75, 80, and so on. Okay, so for our formula, we would go a sub n equals our starting 65 plus that growth 5 times n. Okay, now we want to know how many weeks, so we want to know when this will be equal to 150. So 150 would equal 65 plus 5n. So subtract 65, which that would give us 85 equals 5n. Divide by 5, and n would equal, let's see, 5 goes into 85 once, 35, so 17. So 17 weeks she'll have the 150 hours. Alright, so there we go, guys.